Lesson 6.4, the Archimedes Principle. If you are new to this channel, please do not forget to subscribe, hit the bell, and do some comments. I post educational videos twice a week, every Tuesday and Thursday. So, let's get started. Our lesson 6.4 has the following goals. Goal number 1, to explain why some objects float and some objects sink. And goal number 2, to solve problems involving buoyancy. Who is Archimedes? Archimedes from 287 to 212 BC, preeminent Greek mathematician and inventor who wrote important works on plane and solid geometry, arithmetic, and mechanics. The Eureka story. Archimedes has gone down in history as the guy who ran naked through the streets of Syracuse shouting Eureka, or I have it, in Greek. The story behind that event was that Archimedes was charged with proving that a new crown made for Hieron, the king of Syracuse, was not pure gold as the goldsmith had claimed. The story was first written down in the 1st century BC by Vitruvius, a Roman architect. Archimedes thought long and hard, but could not find a method for proving that the crown was not solid gold. Soon after, he filled a tub and noticed that water spilled over the edge as he got in, and he realized that the water displaced by his body was equal to the weight of his body. Knowing that gold was heavier than other metals, the crown maker could have substituted in. Archimedes had his method to determine that the crown was not pure gold. Forgetting that he was undressed, he went running naked down the streets from his home to the king, shouting, Eureka, Eureka. Here is the Archimedes Principle. When an object is totally or partially immersed in a fluid, it experiences a buoyant force equal to the weight of the fluid displaced. This principle is most frequently applied to the behavior of objects in water and helps to explain floating and sinking, and why objects seem lighter in water. It also applies to balloons in the air. When an object is totally or partially immersed in a fluid, whether it is liquid or gas, some fluid must be pushed aside to make room for the object. This is called the displaced fluid. It should be obvious that the volume of the displaced fluid is equal to the volume of the immersed object. This principle applies to both floating and submerged bodies and to all fluids, that is, to liquids and gases, and to solid materials that behave plastically over long spans of geologic time. To understand buoyant force and flotation, there are three possibilities. 1. If the buoyant force equals the weight of the object, it remains static and has neutral buoyancy. Number 2, if the buoyant force exceeds the weight of the object will accelerate upward. In other words, it will float and is said to have positive buoyancy. And number 3, if the buoyant force is less than the weight of the object, it will sink and is said to have negative buoyancy. In equation form, Archimedes' principle is written as F sub B equals D sub L times B sub SUB times G, where F sub B equals buoyant force in newtons, D sub L equals mass density of the liquid in kilograms per cubic meters, and B sub SUB equals volume of the object that is submerged or immersed in cubic meters, and G is the acceleration due to gravity in meters per second squared. How do boats or ships float? Obviously, the density of a metal rowboat or a concrete canoe is greater than the density of the water, but they float because they contain a large amount of empty space. Because of their shape, they displace enough water to balance their own weight. How do submarines dive and surface? Does the buoyant force change? No. A sub has ballast tanks that can be filled with water or air. To dive, a sub must become heavier so the tanks allow water in while venting out air. To surface, a sub must become lighter. A supply of compressed air on the sub is used to force water back out of the ballast tanks. Let us do some examples now. A 0.001 meter cube of steel is submerged in pure water. What is the magnitude of the buoyant force acting on the steel? Solution. Using the formula FB equals DL times B sub times G, where DL is the density of pure water, 1,000 kilograms per cubic meter. B sub is 0.001 meter cube. G is 9.8 meters per second squared. Substituting the values and simplifying, we have F sub B is 9.8 newtons. Example number 2. A 0.001 meter cube of steel is submerged in mercury whose density is 13,600 kilograms per cubic meter. What is the magnitude of the buoyant force acting on the steel? Using the formula FB equals DL times B sub times G, where DL is now 13,600 kilograms per cubic meter for mercury. B sub is 0.001 meter cube and G is 9.8 meters per second squared. Substituting the values and simplifying, the buoyant force is 133.28 newtons. Example number 3. A 5 times 10 to the minus 6 meter cube of block of lead weighs 0.55 newton. The lead is carefully submerged in a tank of mercury. Density of mercury is 13,000 kilograms per cubic meter. What is the weight of mercury displaced by the block of lead? Will the block of lead sink or float in the mercury? Solution. The weight of mercury displaced by the block of lead is equal to the buoyant force. Using the formula FB equals DL times B sub times G, where DL is 13,600 kilograms per cubic meter for mercury, volume submerged is 5 times 10 to the minus 6 meter cube, and G is 9.8 meters per second squared. Substituting the values and simplifying, the buoyant force is 0.6664 newtons. Since the buoyant force 0.6664 newtons is greater than the weight of lead, which is W equals 0.55 newton, then the block of lead will float in the mercury. Example number 4. A 10 times 10 to the minus 6 cubic meter block of paraffin, which is a type of wax, weighs 0.085 Newton. It is carefully submerged in a container of gasoline. The density of gasoline is 680 kilograms per cubic meters. What is the weight of gasoline displaced by the block of paraffin? Will the block of paraffin sink or float in the gasoline? Solution. The weight of gasoline displaced by the block of paraffin is equal to the buoyant force. Using the formula FB equals DL times B sub times G, where DL is 680 kilograms per cubic meters for gasoline, volume submerged is 10 times 10 to the minus 6 cubic meters, and acceleration due to gravity is 9.8 meters per second squared. Substituting the values and simplifying, we get the buoyant force is 0.067 newtons. Since the buoyant force 0.067 newton is less than the weight of the block of paraffin 0.085 newton, the block of paraffin will sink in gasoline. Example number 5. A block of steel is submerged in water. If the magnitude of the buoyant force acting on the steel is 0.125 Newton, find the volume of steel that is submerged in water. Solution. We are given the buoyant force is 0.125. The density of the liquid, which is pure water, is 1,000 kilograms per cubic meter, and G is 9.8 meters per second squared. We are required to find the volume of steel that is submerged in water. From the formula, FB equals DL B sub times G, and solving for B sub, we get B sub equals FB over DL over G. Substituting the values and simplifying, we get B sub equals 1.276 times 10 to the minus 5 cubic meter, or 12.76 cubic centimeters. Thanks for watching. Please do not forget to subscribe.